Right, circle theorems. Let's do this. So calculate the acute angle AOC. That's going to be this one here. The thing that jumps to mind is the angle at the center circle theorem, because I've got an angle at the center and I've got an angle at the circumference. And this is what the circle theorem says. It says if you have a setup like so, then this one is twice what this one is. I'm not going to prove it, but I will talk about the idea of proving it at the end. And I'm going to basically do exactly the same here. This is one way of doing this question. I can call this 2x, I can call this x. Now that's really useful because I know that if I add up the three angles, then I'm going to have x plus 25. And so this angle in red is the one remaining in the quadrilateral, and it's going to be 360 minus that, which is going to be 335 minus x. So that's what this is, 335 minus x. I can now form an equation. I can write down that 335 minus x plus 2x is equal to 360, because that's the angle around a point. So what am I left with? Let me just simplify it. I'm left with 335 plus x equals 360. So x is going to equal 25, and 2x, which is the angle I want, is going to equal 50. Okay, one way of doing this question. If you don't like that, then you're probably going to resort to ideas that surround the proof of this theorem. And essentially, to prove this theorem, you would work more generally. You wouldn't use these angles, you would use A and B, but you can draw a line that goes from B to O that creates two isosceles triangles. So this must be 15 as well, and this angle must be 10. And you could even then say that's 25, and so the angle at the center is going to be 50. That would be a way of avoiding it algebraically. If you want to completely avoid algebra, then you can then work out this angle, because you know I can use this isosceles triangle on the right. So the blue angle must be 160 to make it add to 180, and then this red angle, this must add to 30, so this must be 150. And doing 316 minus 310 would again give me 50 degrees. So I've kind of talked about three ways of solving it, to be honest. And I like this last way to some extent because it is essentially, it gives you the proof of the circle theorem. If we were to work more generally involving A and B, we could actually prove that the angle at the center is twice that at the circumference. Okay, one more circle theorems question. Explain why angle HDF is 82 degrees. That's going to be this one. Okay, I'm going to do it quickly and then I'm going to talk about a bit more explanation. So we can write down, in fact, that angle EDG, that's this one here, is equal to 55 degrees by the alternate segment theorem. Whenever you see a tangent next to a circle and then a triangle drawn inside, it's pretty much always going to be the alternate segment theorem. Yeah, it says that these two are the same. And then we're basically there. So angle HDF is going to equal 180 minus 40 minus 43 minus 55, which is in fact 82 degrees. I should probably, because it's explain why, I should probably just write in brackets angles on a straight line at 280. Okay, Now, watch on if you're curious, like where did that alternate segment thing just come out from? Okay, let's have a look. This is just one way of showing it. So let's say I draw a circle, I put a point and I draw a tangent. This is only a rough sketch, and I can draw any triangle inside. I've drawn it there. Okay, what I can do is I can put the center in, and then I can basically do an angle at the center kind of argument. So I can first of all see now that I've drawn a radius and I've got a tangent, that this is actually equal to 90 degrees. That's a different circle theorem that I'm using. And then let's call this angle x. So it must be by the angle at the center circle theorem from previous that this is 2x. And because now I've got an isosceles triangle, it must be that these two are the same, yeah, because these lengths are the same, and they have to add up to 180 in total. So these blue ones, if I need to do 180 minus 2x, and I need to divide that by 2, which is the same as doing 90 minus x. So each of these blue angles is 90 minus x. And if that blue angle is 90 minus x and that red angle is 90, it must be that this is also x. And although I've not written all my reasoning down, I have said it verbally, and I have proven that these two will be equal, and they will always be equal. And in a similar way, you will also get that this angle here that I'm now shading in is equal to this angle here that I'm shading in, because it works, you know, symmetrically. If these two are equal, then it must be that those blue ones are equal as well.